name is Balaji Sethuramasamyraja. I'm a faculty member at the Department of Industrial Technology. I represent the Erlen Beverly Knobloch Robotics Lab on the first floor of this building, which I jointly operate with Lyles College of Engineering, with Greg Crane and Walter Mizuno. Good collaborators, we complement each other, great collaborative efforts there with drones and application of sensors. My area is on precision agriculture. I'll talk a little bit about what precision ag is, the potential for application of technology in agriculture, and also talk about some of the projects that I'm involved with. So this presentation is more, focus on my program area. So precision ag is a management strategy that uses information technologies to bring data from multiple sources to make decisions on crop production. Okay? Typically, we are looking at using information. By information, I mean data from the farm using sensors, GPS, other advanced analytics. You take all the data, you look for ways to. So.
It won't show on that screen.
That's fine. Okay. So using the data, we make decisions on how to improve the profitability of the farming operation. Also protect the quality of the environment by site-specifically applying pesticides and fertilizers, avoiding overuse, and also documentation of all the data that the farm operates in for better sociological and cultural practices development. Okay, so it's all about profitability. We're looking at two ways. One is to increase the revenue by reducing the cost. The way we do it is reduced seeding, right? Better application of water. My colleagues talk about CIT and all the initiatives at CIT. We precisely apply water as compared to just throwing it away. And also the timing, scheduling of water, and how the plant growth model works with water retention. Also fertilizer, pesticides, reduce tillage in terms of energy, and also we can use the information to increase the quality, traceability, and also other aspects of organic farming. So the best part of being an ag engineer is that I get to work with all the crops. So I work with wine grapes, almonds, cotton, row crops, pistachios, and with machinery, with systems. So it's been a fun experience, at Fresno State. Besides cropping system, we also work with aspects of farming operations that includes irrigation systems, application of fertilizers, manure, yield mapping, preparation of land, mapping, soil properties for making recommendations. So this is all my research area. Okay. So ultimately, by using technology, we can enhance, farming operations through precision ag. All right. So this is the information cycle, kind of simplified version of it. So we have the farm, and we can, collect data using multiple acquisition systems on soil, water, plant, yield, remote sensing, georeferencing, and then we take the data and do analysis using all kinds of software. One would be GIS, and more we are looking at data analytics, big cloud technology, big data in farming. I in fact have a National Science Foundation grant on smart farm where we use data analytics using cloud computing to make decisions for farming operations. And of course, ultimately when you have that information, we need to apply them, right? So that's where variable rate technology comes into place. So based on the information that we have, we can do precision irrigation, variable rate application of fertilizer, variable rate application of pesticides, and whatever inputs that you can think about. Okay, so there is potential for research in all these avenues in farming. And like I mentioned, I have this smart farm NSF grant on farm automation. We are looking at multiple ways in which we can automate collection of data on the farm, do data analytics on the cloud, and then drive that data back to the farmer using DIY, do-it-yourself kits that will make it easy for farmers to do their day-to-day operations. I also have a joint grant with Greg. He talked about it quite a bit this morning, the earlier part of the presentation, where we're looking at almond water stress, using AeroVironment drones and sensing technology. I'm also interested in Internet of Things, so I'm willing to work with College of Engineering faculty members. Ajit is here, is one of my collaborators. We have a grant together. So that's one of the areas I'm interested in. Sustainable agriculture, water, I have a research contract with Jain Irrigation. We are developing a wirelessly controlled smart irrigation system that can be deployed on center-pivot systems. I have a soil library for calibrating sensors across the whole range. So I'm working on building and expanding the soil library. I have 5 soils right now. And I also have Trimble WM Topo DEM mapper that helps define the DEM layer based on which you can make irrigation system designer and other things. So yeah, these are all the tools that we play with: GPS, GIS, multiple variable rate technology, yield mappers, sensors and controls, soil sampling analysis, plant scouting, on-the-go technologies. So I'm interested in all these areas. Some of the examples, we built an almond harvesting system that can map yield on the go, and also a wine grape differential harvesting system. We also did some GIS analysis on cotton yield variations with other parameters. So like I said, I have multiple collaborators here. I've missed Florence, Dave Gurabu, I work with them as well, besides the ones I mentioned before. Thank you.
Thank you.